In question 5, we have a diagram in which a triangle ABC is a right angle at C and M is the midpoint of BC. It is given that angle ABC is 1 upon 3 pi and angle BAM is theta. BM and MC are given by X. We have to find AM in terms of X. Now to find AM in terms of X, we'll have to first find the length of AC. So first drawing the triangle ABC. So this is A, this is C, and this is B. The total length of BC will be 2x. This angle is 1 upon 3 pi. So to find the length of AC, in the first part, we can use opposite over adjacent tan. So tan of 1 upon 3 pi will be is equals to opposite, which is AC upon 2x. So tan of 1 upon 3 pi, if we substitute this in the calculator, we'll get root 3 is equals to AC upon 2x. So AC will be is equals to 2 root 3 of x. Now to find the length of AM, we can now draw the triangle ACM. So if we draw the triangle AC and M, we know that the length of AC is 2 root 3 of x. And this length is x and this is a right angle and this is M. So now we can use Pythagoras theorem. As AM is the hypotenuse, we can write AM squared is equals to x squared plus 2 root 3x whole squared. Simplifying this, we'll get AM squared is equals to, and this was a 2x whole squared. So the length of MC is x, so this will be x squared. So this will become x squared plus 2 root 3 is 2 root 3 whole squared will become 4 times 3, which is 12. So this will be 12x squared. So AM squared will be 13x squared. Taking the square root on both the sides, we'll get AM is equals to square root of 13x squared. For the square root of x squared, the square will cancel. So we can write the length of AM as equals to square root 13 and x. In part 2, we have to show that the angle theta is 1 upon 6 pi minus tan inverse of 1 upon 2 upon 3 pi, 2 root 3 pi, 2 root 3. Now we know that ABC is a triangle. This is a right angle, which means this angle and this complete angle will be pi upon 2 or 90 degrees. As this is already 1 upon 3 pi, we can say that this total angle, so the angle BAC, so for part 2, angle BAC will be is equals to pi upon 2 minus pi upon 3. Simplifying this, we'll get 3 pi minus 2 pi, which will become pi upon 6. So the angle BAC is pi upon 6. Now, as we are trying to show that theta is equals to 1 upon 6 pi minus tan inverse of 1 upon 2 root 3, so we'll have to use a right angle triangle. So this angle will be pi upon 6 minus theta. So angle MAC will be is equals to pi upon 6 minus theta, as the total angle was pi upon 6 and this angle was theta. We already have the length of MC, which is x, and the length of AC we found in the last part, which was 2 root 3x. So now applying tan again, as this angle MAC is pi upon 6 minus theta, we can say that tan inverse of pi upon 6 minus theta will be is equals to opposite, which is MCX, and adjacent, which is the length of AC, which is 2 root 3x. X and X will cancel, and this was just tan, so this will be tan. So now taking the tan inverse, we will get pi upon 6 minus theta is equals to tan inverse of 1 upon 2 root 3. To find theta, we'll take it on the right hand side and bring tan inverse on the other side. So this will become pi upon 6 minus tan inverse of 1 upon 2 root 3, and that will be equals to theta. So we have to show that theta is 1 upon 6 pi. So we have pi upon 6 minus tan inverse of 1 upon 2 root 3. So we can see it has been proven.